Welcome, my dear student. Last video we learned about the decay constant. The equation of exponential form of decay constant Nt is equal to N0 e raised to minus lambda t. Today we have learned about the topic, that is the concept nuclear transmutation or the artificial disintegration or the atomic transmutation. Transmutation means there is a change in composition of a nucleus. Artificial transmutation can be defined as the process in which one type of nuclei is converted into another by bombarded with the various projectiles on it. That is the one type, that is the nuclear, that is a target, and target on which the projectile get bombarded. The process of converting one element into another element by bombarding it with fast moving particles is called as atomic transmutation or artificial disintegration. Rutherford in 1919 discovered that when fast moving alpha particles were passed through a nitrogen gas filled in a glass tube, the protons of long range were produced. The 7-nitrogen-14 is a target nucleus, that is a parent element on which the alpha particle is bombarded, that is a 2He4. The nitrogen with the alpha particle gives the 8 oxygen 17, that is a recoil nucleus, or it is called as the product nucleus or the daughter nucleus. And the proton 1H1, that is the ejected particle, that is the emitted particle, means nitrogen which is bombarded with the helium gives the oxygen recoil nucleus and the proton. The This reaction is a written shortened notation, Bentman notation, that is 7 nitrogen 14. In a parenthesis, there is a alpha comma proton, parenthesis complete, then outside there is a 8 oxygen 17, means a alpha p type of reaction. 7 nitrogen 14 in parenthesis alpha comma p, then outside 8 oxygen 17. In a nuclear reaction, two rules are obeyed, that is the conservation of charge and the conservation of nucleons or nuclei. The conservation of charge means the total charge on both the sides must be same, and conservation of nucleons means the total number of nucleons or nuclei must also be same on both the sides. The mechanism of nuclear transmutation is explained on the basis of compound nucleus theory. The nuclear transmutation reaction takes place in two steps. That is the first step, that is a projectile is absorbed by the target nucleus, means the target nucleus captures the projectiles to form the compound nucleus. The compound nucleus possesses the total energy of the target nucleus and the projectile. And second step, in which the compound nucleus then decays, disintegrate to another nucleus with the emission of particles. Means the nitrogen with the alpha particle, it gives a 9 fluorine 18. It is a compound nucleus that is unstable. It possesses more energy. The energy content of compound nucleus is increased by the kinetic energy of a projectile. The mode of decay depends on the nature, charge and mass of the projectile. The 9 fluorine 18, it gives the various isotopes and the particles. The particles gamma, neutron, proton, deuterium, then helium-4, helium-3, etc. The transmutation by alpha particles by comma the protons, comma deuterons, neutrons, gamma rays, etc. Examples: alpha particles as a projectile. The 7 nitrogen 14 plus twice He4 gives the 8 oxygen 17 plus 1 hydrogen 1 means alpha p type of a reaction. Another, that is a 4 beryllium 9 plus alpha particle twice He4, it gives a 6 carbon 12 plus 0 and 1 neutron means alpha n type of a reaction. The neutron as a projectile, the 5 boron 10 plus neutron, it gives the 3 lithium 7 and the helium, that is a twice He4 alpha particle means n alpha type of a reaction. The 12 magnesium 24 plus neutron, it gives the La1 sodium 24 plus proton means a neutron proton reaction. The protons acts a projectile. The lithium 7 plus proton, it gives the helium twice He4 plus twice He4 means there is a proton alpha type of a reaction. The 13 aluminum 27 plus proton, it gives 14 silicon 28 plus gamma, that is a p gamma reaction, proton gamma reaction. Then another, that is the deuterons as a projectile. The 48 cadmium 114 plus deuterium, it gives the 48 cadmium 115 plus 1H1, that is a proton, deuterium proton type of reaction means the alpha particle as a projectile, neutrons as a projectile, protons as a projectile, deuterons as a projectile, and the deuterons which bombard with the 6 carbon 12, it gives a 5 boron 10 plus uh, alpha particle twice He4 means D alpha type of reaction. Another, that is 83 bismuth 209 plus 1D2, it gives the 84 polonium 210 plus 0 and 1, that is neutron, the D N type of reaction. Another type of nuclear reaction, that is gamma rays as a projectile. The deuteron plus the gamma, it gives the proton plus neutron, that is a gamma n type of a reaction. 1D2 plus gamma, it gives 1H1 plus 0 n1, that is a gamma n type of a reaction. Another, that is a 6 carbon 12 plus gamma rays, it is a very high energetic condition. It gives the 4 beryllium 8 plus twice He4, it gives gamma alpha type of reaction. It is a gamma alpha type of reaction. Gamma ray is bombarded, alpha, that is emitted. Another concept, that is artificial radioactivity, or it is called as induced radioactivity. The light nuclei are naturally stable and non-radioactive, but it is possible to convert the stable and non-radioactive nuclei of isotopes into the radioactive ones by atomic transmutation. That is the bombarding the stable nuclei with the different particles, that is the projectiles. Thus, the process of converting a stable nucleus of one element into unstable nucleus of another element by bombarding it with fast moving particles such as protons, neutrons, deuterons, alpha particles, that is the projectiles. Means the converting of stable nucleus uh, into unstable nucleus of another element by bombarding with the projectiles is called as the artificial radioactivity, or it is called as induced radioactivity. In 1934, Erin Juliet Curie and F. Juliet discovered that when aluminum, boron, or magnesium is bombarded with the alpha particles, in addition to neutrons, there is a positrons, that is, a positive electrons are also emitted. When the source of alpha particles was removed, there is a emission of neutron star, but the positrons continue to be emitted by the sample within the time. The recoil nucleus being unstable and becomes radioactive and emits the positrons. The daughter nucleus radioactive and it attains a stability either by emitting a positron or the electron depending on its neutron to proton ratio. means a neutron to proton ratio, n for neutron, z for the proton. N by z is equal to 1. For example, the transmutation by alpha particle 13 aluminum 27 plus twice He4, it gives a 15 phosphorus 30 plus 0 and 1 means neutron. Phosphorus 30, it is unstable, it is radioactive, but the 15 phosphorus 31, it is stable. Means phosphorus 30 is not stable, unstable and radioactive, and 1 neutron is less. The 15 phosphorus 30 decays to gives 14 silicon 30 plus positron plus 1 E0. The positron, it get formed from the aluminum disintegration, then it is a half-life to about the 3 minutes. Another, that is a n by z ratio is less than 1, means the n by z ratio of a daughter nuclei is less than 1, and it attains the stability by emitting the positron. The 12 magnesium 24 plus twice He4, it gives the 14 silicon 27 plus 0 and 1 means alpha n type of reaction. This silicon is unstable, radioactive. The 14 silicon 27, it gives the 13 aluminum 27 plus the positron plus 1 E0 means here this reaction, the nitrogen proton is less than 1 means proton number is excess, nitrogen number is less means proton 1p1, it gives the 0 and 1 plus the plus 1 E0 means the proton is converted to neutron and the positron if the n by z is less than 1. Proton excess, proton is gives the nitrogen and positron. In case of secondary, if the n divided by z of daughter radioactive nuclear form is greater than 1, then it attains the stability by emitting an electron. Means there is a emitting of electron, means what here there is a nitrogen to proton ratio is greater than 1. Mean nitrogen number is more as compared to proton number, means 0 and 1, it gives 1 P1 plus minus 1 E0 means there is a neutron gives the proton and the electron. For example, if you consider the reaction, nuclear reaction in P type of reaction, 7 nitrogen 14 plus 0 and 1 means nitrogen is bombarded with the with the neutron, then the 6 carbon 14 plus a proton is emitted. 6 carbon 14 is unstable, radioactive, and it gives the 7 nitrogen 14 plus the electron minus 1 E0 means the nitrogen is bombarded with the neutron, it gives the carbon 14 and proton alpha p alpha, NP type of reaction, and the carbon 14, it gives the nitrogen 14 and the electron. The consider for the artificial radioactivity and the natural radioactivity, we distinguish them. The natural radioactivity phenomena is observed in uranium, that is a radioactivity of uranium. The natural radioactivity and artificial radioactivity, in which the natural radioactivity is a process, is a spontaneous, unstable nucleus having atomic number greater than 82. The heavy unstable nucleus that can be disintegrated and radiations are emitted. In case of artificial radioactivity, the nuclei of light element are quite stable, but they are made unstable by bombarding with the projectiles, alpha particle, neutron, proton, etc. The natural radioactivity, in which nuclear emits alpha, beta and the gamma rays, but the artificial radioactivity, in which the nuclear emits positron or the electrons. Natural radioactivity, in which they form radioactive series of elements. Radioactive series of elements, that is a uranium series, thorium series, actinium series, plutonium, Neptunium series. Uranium, thorium, actinium and Neptunium series. The series in which the final ending with the stable isotope lead in uranium, thorium and actinium series. The artificial radioactivity in which no radioactive series of element is formed. The natural radioactivity in which large amount of the energy is released, and the artificial radioactivity in which energized projectiles have to be used to induce the artificial radioactivity. The natural radioactivity, there is no external control over the natural radioactivity. But in case of artificial radioactivity, it can be controlled by regulating the flow of projectiles. In case of natural radioactivity, there is no electron capture can takes place. There is no internal conversion. But in case of artificial radioactivity, there is a K electron capture can takes place, or there is a internal conversion. Means the artificial radioactivity in which there is a neutron proton ratio is equal, or neutron proton ratio is less than 1, neutron proton ratio is greater than 1, then there is a formation of that daughter elements from the parent elements. Thank you.